So essentially, we started out with a simple example of finding the price of a house. Towards that, we sort of collected what is known as features, and we wanted to find the function that maps features to a number called the price, right? So the other assumption that we made, typical assumption that people make is, for example, the relationship between the price and the features is linear. So you can just assume that y is w1, x1, and so on. And you add an error term, which is the model error, right? For example, it need not be linear. It can be, let's say, second order polynomial. Then this noise will capture that difference. Okay, then in general, suppose if f is the function, how do you find this function f based on the data? So you collected the data and then figured out, so the way to figure out what f is through this equation, right? This particular problem, right? You minimize over all possible functions, that you minimize the squared error with respect to all possible function f, right? And this is a very complicated problem. Therefore, you use certain assumptions on f. So this sort of motivates optimization problem. You need to solve optimization problem in many situation in data science, many cases in data science. The second problem that we looked at was matrix completion. So movie rating problem, where it turned out that a suitable problem to solve is minimize what is called rank of a matrix, subjected to the constraint that wherever you have entered, the people have entered the rating, it should match, right? Wherever you haven't entered, you should be able to figure out that those values. Okay, so essentially, this motivates not only optimization but also linear algebra, right? So you need to know what rank is. You need to know how do you minimize what kind of a function is rank, and so on. Okay, so the third example that we looked at was spam versus non-spam problem. So essentially, there is an incoming email, and you have to figure out whether it's spam or non-spam in an automatic fashion. So what you do is you remove all unnecessary words like articles like an, a, and so on. And then you have a bag of words called dictionary, and you count the number of times each word in this bag of words appear, right? That you call it as feature vector here, x1 through xk. Okay, so now the problem is, the problem boils down to, given this feature vector, you have to say whether it's +1 or -1, right? Spam or non-spam. Okay, so the other important thing to observe is these data are getting generated in a random fashion, because beforehand you don't know so what kind of data will appear. So a nice model for that is probabilistic or stochastic, right? So you can assume that these data are generated according to some probability distribution. So probability theory is in fact at the core of mathematics for data science, which is something that we don't study in this particular course. You have already studied, and there is one more course in the next semester called stochastic processes, which you will end up taking, wherein we will study much more than the first course in probability theory. Okay, so now let's revisit the problem of spam versus non-spam. So what is that? So suppose you have the data, right? So you have the feature vector and you have the labels. Supposing, imagine that you could plot this particular, these features, right? So what I'm going to do is imagine that you could plot it in 2 dimensions, although it could be in, let's say, 10,000 dimensions if you are using a bag of words consisting of 10,000 words. So what we do is, imagine that you could plot it in 2 dimensions. So supposing, let's say, I use plus for spam and minus for non-spam. So this is how it looks like. Let's say plus all the points are somewhere here. Okay, so these are all points corresponding to spam. Okay, x1, x2, and so on. Right? And similarly, you have non-spam. Let's say it's somewhere here. I'll write it as minus. Right. So you have a lot of such data points. Okay. Maybe once in a while you have a minus here and maybe you have a plus here. Okay. But that's okay. So what can you say from this data pattern? Obviously, the plus signs are on one side, minus signs are on the other side. That's the pattern, right? An obvious pattern that you can immediately recognize. Now, if you have to separate these 2 patterns, what is it that I have to do? Basically just draw a line, right? Maybe a line like this, right? Which will separate the two patterns, right? Well, if it is not in 2 dimension, let's say it's in 3 or higher dimensions, then the line wouldn't suffice, right? You have to put a plane that separates the two data sets. Do you agree? So now, what do you mean by learning or machine learning in this case? A very crude answer. So let me write that. What is ML here? A very crude answer is what? Can somebody guess? Can somebody guess? Okay, people who are here in the auditorium, can somebody guess? Okay, getting line equation, that's what somebody says. So that's correct, right? So if I know the line, I can say whether the point is to the right or left, right? So if it is to the left, I say it's a spam. If it is to the right, I say it's non-spam, right? It's as simple as that. So the answer would be finding the line or a plane, right? Finding the plane. So how do you find this plane? So before that, I need to know what is this equation of a plane, right? So what is the equation of a plane? Can somebody tell me what is the equation of a plane or a line? Line is mx plus c, right? So of course, everybody knows. What is the equation of a plane? It's something like A transpose, yeah, ax plus by plus cz equal to something, right? In general, I can write ABC as a vector and xyz as a vector. So I can write it as W transpose x, right? So W is like ABC, right? So the equation of the line would be W transpose x plus B, right? It's almost like mx plus c, right? So why this represents a plane is something that we will look at when we study linear algebra. So this is the equation of a plane, okay? So now, what do you mean by learning? Learning means I need to know what is this W and what is this offset B, right? So if I know these, know the plane, and therefore I can figure out whether an incoming email is a spam or non-spam. Okay, so now how do you find that? Again, you have to pose an optimization problem that will end up giving us the spam or non-spam, the W and B, right? So how do you, supposing let's say I give you W and B, that means I know the equation of a plane. So suppose there is an incoming email, I convert that into feature X. So you are supposed to tell me whether it's spam or not spam. Let's say you are to go and program or implement it on a hardware or whatever, right? So you have to write a program. Then what do you do? So essentially, what you do is you have W transpose. Of course, you have that. X is the incoming feature plus B, right? So this gives me a number. Do you agree? W transpose X plus B. Now I have to say whether this feature or the point corresponds to the point to the left of the hyperplane or to the right of the hyperplane, right? That's all I have to say. So how do you say that? Well, it's simply the sign, right? Sign of W transpose X plus B will tell me if it is positive, it's to the right, or negative, it's to the left, and so on, right? So this is how I can decide whether the point is to the left or right, right? Do you agree with this, right? Okay, now supposing I have this data, right? So x1, you have y1, x2, y2, and so on. Let's say xn, yn. You have n data points. So how do you figure out this plane, right, given these data points? So of course, yi is basically +1 or -1, right? Spam or non-spam. So what do you do? So for example, what you do is you take this, right? So sign of W transpose xi plus B, right? So for the ith data point, this will tell me whether it's spam or non-spam, or supposed to tell me whether it's non-spam or spam. So the sign will tell me whether it's +1 or -1, okay? So it's not really sign, it's slightly offset, okay? So maybe I will say, so if it is sign, what does that mean? What will it give us? Sine function. What is sine of x? If you plot it, how does it look like? How does it look like? If it's positive, you will get what? Huh? You will get 1, and negative it's 0, right? It's something like an indicator. or okay, so let's define my own sign here. Okay, so sign is sign of x in my case would be +1 if x is greater than 0, -1 if x is less than or equal to 0. Is that okay? I'll define my own sign here. Okay, so now this sign here, sign of W transpose xi plus b, will give me whether, will tell me whether xi, the ith data point or the ith email, is spam or non-spam. So now I have to check whether it is true or not, right? So I have to check whether it is equal to yi or not equal. Whenever it's not equal, I have made a mistake, right? The hyperplane that I have considered is not a good hyperplane, right? So this is the error event, right? So whenever this happens, there is an error. So essentially what I have to do is to count the number of errors given these endpoints. So let me count this, I equal to 1 to n. So how do I count? Before that, how do I count this? Sign of W transpose xi plus b not equal to y. So this is an event, right? Whenever this happens, I should say 1. Otherwise, I should say 0, right? So that's called indicator. How many of you know what indicator function is? Indicator of x is 1 whenever x happens, right? So indicator of a is 1 whenever a happens, otherwise 0. Okay, is that fine? Whenever the sign is not equal to yi, it will be 1, otherwise it will be 0. So I'll count this, right? The total number. This will give me the total number of mistake that my plane would have done, right? So what I do now is I have to minimize this overall w, the vector w, and the bias or the offset term b, right? So if I could figure out what this b, w and b are, then I know what the hyperplane is, right? So this essentially gives us some w hat and some b hat, right? Right? So now what do I do in the future? So I just write a program wherein I take the input feature. How do you get the input feature? Easy, right? You take the mail, throw away A, B, C, A and D and all that. You have the bag of words, count the number of words that appear. You get the vector and take W1 hat, multiply by X1, W2 hat, multiply X2 and add them, plus add a bias B hat. Look at the sign. If it's positive, you say spam, otherwise you say non-spam, right? As simple as that. Now let's look at the implementation of this, right? So pictorially. So here we have the input. Okay, so we have, let's say the input is your feature, right? X1, X2, X M. Okay, so let's assume that you have M. This is your input feature. I'm going to feed it into this. So what do I do here? I take W1 hat, multiply the input X1 by W1 hat, multiply X2 by W2 hat, and so on, multiply this by WM hat. Okay, M hat or N hat. I think I've been using these two things interchangeably, but it does not matter. Okay, so is this clear? And add them. Okay, and I have to add a bias B hat, right? So now what do? I do sign. And this will tell me, well, +1 or -1, right? Have you seen this kind of an architecture before? Those of you who have studied or looked into, let's say, some part of machine learning, what is this? Okay, offline people. So, okay, yes. Somebody told something, that's correct. Right? Yeah, so it resembles perceptron, right? Right? Okay. Yeah, so I think Suman says it's neural net or perceptron. Yes, this is a simple implementation of a neural network, right? So you know the motivation, right? Why one should go for neural net. Okay. So let's go beyond this. So the problem is, you know, you have to solve this problem, right? Minimize, some of indicators of sign. Sign is also a very bad function, right? It has abrupt jumps and all that. Indicator is equally bad, right? Now, if you have some bad functions that I need to optimize over, it's optimize those functions, then it's really not a good idea, right? It becomes very hard in terms of finding out or optimizing this particular functions, right? So what do? So I have to make some make some replacements that are nice, right? Proxies for the actual thing that I need. So what do you think is sine here? So let's plot sine. Okay, so what is sine? Well, sine here is this. It's +1 or -1, right? Well, there is an abrupt jump and it's constant. So if I want to replace this by a nice function, what do you do? Yeah, something like this, right? This is the first thing that people would have looked at, right? Do you agree? Well, if you use this in practice, what do I get? Suppose the x is here, you won't get +1 or -1, right? You'll get some positive values. But remember, I can optimize, right? That's the good thing. So what do I do? So, typically in machine learning, you use so many, this is called an activation function, right? So you replace this with something nice, right? This something nice would be what is known as activation function, right? You have tan hyperbolic and so many activation functions that people use. Okay, is this fine? Okay, so indicator I have to replace, right? What do I do with that? There are ways, right? So I can look at the difference mod, I can look at squared error, whatever, so many errors. But if you're looking at 1 minus 1, there are other loss functions. For example, there is cross entropy loss and so on, right? Which we won't get into because that goes deep into the world of machine learning. But you should know that there is something called cross entropy and this other measures which can be used in this scenario, right? Which are nice. Okay. So now we have one neural network. So essentially, what is a neural network now for us? A neuron. It's a hyperplane, right? That's all. Now, suppose I have, it turns out that your data points when you plotted, it's not as nice as what you observed in the previous slide, right? So supposing, you have slightly more complicated. Okay, let me write that slightly more complicated. It looks like this. So plus is here, okay, all splams. Okay. And you also have, let's say, non-spam, right? So non-spam as before, let's say it's like this. Sorry, this is minus. And there are a few minuses here also. Now what do you do? Can you use a hyperplane to separate? Huh? What do you do? So the most obvious thing to do. How do you, suppose if you were looking at this, let's say, way back in the 1950s, just after Rosenblatt proposed the idea of neural network. So suppose you were to do the classification here, what is it that you do? Somebody answered curve, right? So yeah, so we can do something like this, right? Very complicated curve, right? Well, I say if it is to the left of this curve, then it's spam, otherwise it's non-spam. Well, nice, right? So good. But what is this curve and how do you denote this curve and how do you optimize? And there are so many questions that one can ask, right? So always whenever you encounter some new problem, always try to convert that into your old problem, right? So somehow convert it into something that you already know how to solve, right? So what is it that you know how to solve? If it's separable by hyperplane, right? So now I can do this cool trick, right? So what is that? I'll put one hyperplane like this, right? Now, if I said if it is to the left of the hyperplane, it's spam, right of the hyperplane, it's non-spam. Whenever you get a point to the right of the hyperplane, you're always good in this case. Whenever it is to the left, you are in trouble, right? Why? It could be spam or non-spam. So what do? Put one more line like this. So now you say, it's like two neurons, right? Two perceptrons. You say first perceptron says it's to the left. The second perceptron says it's to the right. Then you say spam. Otherwise you say non-spam, right? It's really nice, right? So how does it look like this? If you want to implement this, it's easy. Again, you have n points, x1, x2, xm. Okay. So the first one would be W11, W12, W1M, right? I'm going to add a bias. Let me call this as B1 and a sign, whatever. I'll call it a sigma, and this is the output, right? And now what do you have? I have another, right? So I have to write maybe one more like this, right? So what are these? This is W21, W22, and this is W2M, okay? And you add a bias B2, and then you have a sigma. Well, you have the output. So what do I do with this? One more perceptron, right? So it should be to the right or left. So what do I do? What is one more perceptron here? Simple thing. Okay, so I'll not, I'll ask you to fill. Okay, so what is this? This should be -1, right? One more perceptron is actually, you don't need to do anything, right? You can just write an if-else statement in your code. You say the first perceptron says minus, that is to the left. The second perceptron says plus, that is to the right. Then you say spam. Else, non-spam. That's all, right? So 2-3 lines of code. Okay. So now, of course, if you want to have very complicated, let's say there is a data set which is like this, okay? So suppose plus or like this. Minuses or like this. So what do you do now? Well, now you need a complicated curve, right? But can you approximate that curve? Yes, right? So you can always do this. You'll put one line here, one line here, one line here, one line here. So many perceptrons you put together to get any separation. So all that you have to do is make the layer deeper and deeper, right? This way. So then I can represent any curve and I can separate any data point. Okay. Well, there is a deeper theory to this. Well, you cannot always do this and get away with what, I mean, you cannot achieve good performance just by doing this. You have to do something more than this to achieve better performance, which is beyond the scope of this particular course. Okay. So any questions, those who are online, maybe I'll pause for 2 minutes. You can ask questions and then we will move on. Any questions? Those people who are online. No questions? Okay, so I hope they're able to see. Okay, is there a question? So somebody is asking, please explain perceptron. So essentially, the idea is this. I'll quickly go over it. So if you have this kind of a situation, a hyperplane will separate the two. So what is an hyperplane? It's like ax plus by plus cz plus d, right? So that is the equation of a hyperplane. Or I can say abc transpose term plus b. So all that I have to do is w transpose x plus b. So I have to implement that. How do I implement? The implementation is this, right? So x1 times w1 hat plus x2 times w2 hat and so on, xm times w1 hat plus b hat. That gives me the hyperplane equation, right? If I look at the sign of that, that will tell me whether it is to the left or right. Okay, so it's a simple implementation of a hyperplane test. That is what a perceptron is. Okay, so any other questions online, people? Okay, so offline, any questions from people here? No? Yes, fine. Okay. So now I think we will keep revisiting some of these problems again and again over the course, but let's move into the main topic, right? So it's mathematics for data science. It's not data science itself, right? So let's see. Suppose I give you a function, right? So minimize for all x f of x. So how do you minimize this function? So suppose the function is like this. This is something that you need, right? I don't need to motivate why one should solve this problem. we know, right? Suppose I have given the data points or the data, you are supposed to learn a neural network, then I have to minimize something, right? Some function. So suppose the function is like this. Now, this function could be very complicated. One way is you take the derivative equated to 0 and figure out the stationary point and all that, right? But suppose this function is very complicated, right? Meaning, if I say take the derivative equated to 0, it's like very complicated, highly nonlinear equation, which is difficult to solve. So how do you solve this problem? Well, easy, right? So what you do is you randomly start at some point. Let me call it as x0. Okay. Now you look at the derivative at this point, right? Okay, the slope, right? If the slope is negative, what you should do? You should move this point to the left, right? Consider a new point x1, right? You'll get this again slope. Slope is negative, you move slightly to the left of x1 and keep on doing that, right? Eventually you hit this point. We'll see more in great detail what this algorithm is and all that later on. But essentially what you get is a sequence of points. And if you were to implement this algorithm, the algorithm will keep on iterating. And if it will keep on iterating forever, which is not good, right? You should iterate as less as possible and achieve the best, right? In other words, you should go and reach what is known as, you should converge, right? So that's the right word, right? So it should converge to some point which is good, right? Therefore, we need a lot of calculus here, right? We need, what do you mean by limit or the convergence of a sequence? We need to know, for example, these x0, x1, the sequence need not be numbers, right? This could be vectors. So what do you mean by convergence for a vector and so on, right? These are all obvious questions one can ask. Now let's start with the basic, some quick overview of calculus that you would have studied in your first year. I think first year, right? First year or third? I think first year, right? You would have studied these things in the first year. Okay, so let's do a quick review of basic calculus, or you want to call it as real analysis, which will be helpful later on. So I will revisit this again, okay, so for multivariate calculus, but for now, let's look at this. Okay, so suppose I give you a sequence, right? So what is a sequence? Sequence is basically x1, x2, x3, and so on. So by the way, I won't be very rigorous, as rigorous as a mathematician, but if you want to learn more about this, maybe you should read a book on real analysis, which will be it'll be a rigorous treatment. Okay, so you have a sequence, right? X1. Okay, before that, I hope everybody knows what a natural number is. What is rational, irrational, real. Okay, so I'm assuming that. Okay, so suppose I take this sequence, and typically we say, oh, limit of this sequence xn as n goes to infinity is something, right? X star. So what do you mean by that? Can somebody tell me what is the meaning of this? So typically what you do, 1 over n limit n tending to infinity is 0, right? Some intuition you have, you just apply, or if you are really a bad student, then probably, you know, you will apply something, some rules, and then not give the correct answer, or give the correct answer, but you don't know why, right? So can somebody tell me what is the meaning of this? This is very important, right? So without knowing the meaning, there is no point in looking at algorithms, right? So you should know what the meaning is. So can somebody tell me what is limit? What is the meaning of, so that means xn converges to x star, right? So in English. So limit is another way, another language, right? So limit n tending to infinity xn equal to x star. That's exactly like English, but in symbols. But that's not the real meaning of limit, right? So what is the real meaning of limit? No answer? Calculus. I think you would have studied this in your first pre-university, right? So first year Q, or maybe some of you might have studied this in your high school, I don't know. But what is this? What is limit? Any answers? No? Okay, so what do you mean by 1 over n going to 0? This is another symbol, right? So n goes to infinity. Well, 1 over n converges to 0, or limit n tending to infinity, 1 over n equal to 0, or 1 over n converges to 0. All these things are equivalent, right? So in different languages, that's all. So what is the meaning of this? Suppose, let's look at it pictorially, okay? So if xn should converge to some x star, what do you mean by that? So you have this sequence, let's say x star is here, okay? Now what do you mean by converging to this point? It means it goes to closer and closer to x star, right? That is one way of looking at it, right? So what do you mean by going closer and closer? Well, I cannot always say that, it will go and hit x star. Not possible, right? In practice also, when you run an algorithm, there is no guarantee that it will go to the minima, right? It will go closer and closer to the minima, that's all, right? And at some point you say, okay, I'm done, I'll stop, right? So what do you mean by going closer and closer? So let's define the closeness by putting a small ball around it, okay? So I'll put a small interval around it, okay? Let me call this as epsilon of room, okay? Epsilon room. Because the width is epsilon, this is epsilon room around x star. So what do you mean by xn converging to x? So if xn converges to x star, do you agree that it should enter this room? Eventually it should enter, right? And if it start entering and leaving and entering and leaving, do you think it will converge? No, right? So at least we suspect that the moment it enters, there is some stage beyond which, the moment it enters this room, it will stay there forever, right? You should be able to find a stage in the sequence. For example, if you have this sequence x1, x2, and so on, there is a stage, okay? So this is a stage. Let me call it as n epsilon, okay? That means all the sequence, for example, n epsilon, xn epsilon plus 1, and so on, all these sequence will lie in this epsilon room, okay? Right? It should stay there forever. Do you think this will guarantee convergence? Yeah, I can go and sort of oscillate within the room, right? So I can confine you into the room, but you can wander in the room, right? Randomly. So that doesn't mean that it converges to x star. So what extra condition you need? If I make this room smaller, right? For example, I make epsilon room epsilon by 2 room. I squeeze it. What happens then? Right? Now there is a stage. Well, perhaps the stage could come later, right? So maybe here, okay? This is the stage, right? Stage n epsilon by 2, okay? Beyond which all the sequences that you have here will stay inside epsilon by 2 room. Is that enough? No. You want smaller room, right? Smaller and smaller and smaller rooms, right? So now, how do you define convergence, or how do you say that xn? What do you mean by xn converging to x star? It means that you give me any epsilon room, epsilon greater than 0, any epsilon, however small or large, I can find a stage in the sequence beyond which all the numbers in that sequence, beyond that stage, right, will lie inside that room, right? So there is this notion of room, right? So what do you mean by room? Can somebody tell me what is room here in this case? Yeah.
Radius of convergence.
No, I mean, what is room in this case?
The actual limiting value, how close it can go.
No, epsilon room is basically the interval, right? So that leads to the notion of interval, right? So let's look at a few notions there, right? So what do you mean by, so these are ingredients required in order to define limit, right? So our ultimate objective is to understand limit, okay? So in order to understand limit, you need to know what is, open interval and what do you mean by interval, right? Is that fine? So let's look at what is known as open interval, okay? So what is an open interval? You look at all the numbers between two numbers, let's say a and b, but a and b should not be included, right? So an open interval I is of the form, well, I'll call it as, well, what I'm going to do is I'm going to use a notation here. So what is the notation? A comma b, right? This is an interval. It is all the points x on the real line such that a is smaller than x, but b is larger than x. Okay? But x cannot be equal to b, x cannot be equal to a, right? This is an open interval. Okay. Okay, so there are other intervals, right? So I'll not rigorously, I don't give any rigorous definition. So what about this? What is this? It's open on the left, closed on the right, right? What do you mean by that? All the numbers x greater than a, but less than or equal to b, right? So and so on. You have this, you have this. This is called closed interval because you consider all the numbers between a and b included, right? It's a closed interval. Interval is fine, right? Okay. So now let's try to define what is an epsilon room. Epsilon room is basically, an interval around x star. Okay, that's an epsilon room. Okay, so now let's write the definition of, limit. Okay, so convergence. Okay, this is the boring part, right? So you have to turn your intuition geometry into Greek and Latin, right? That's what we will do now. Well, it's not really boring. For many of us, it's interesting. We say that a sequence xn converges to x if you take any room, right? If for every epsilon greater than 0, okay, so epsilon is your room size, right? There exists n epsilon, right? That is your stage, right? Beyond which all the sequences will be done. There exists an epsilon such that now the sequences beyond the stage will always remain within the epsilon room. How do I write that? See, xn should be close to x, right? How close? Epsilon close. This is clear, right? Xn minus x mod is less than epsilon means what? Xn is less than x plus epsilon. Xn is greater than x minus epsilon, right? So the idea is this, right? So xn is, so x is here, right? Epsilon plus x is here. X minus epsilon is here. So in fact, this is not epsilon room, this is 2 epsilon room. That's okay because epsilon I'll take it to be very, very small, it doesn't matter, right? So this is the picture that I have written here is equivalent to xn minus x mod less than epsilon. Is this fine? Any questions? Any questions? I've written the epsilon of room here, epsilon room here. That's all. In fact, 2 epsilon room. Okay. So now I'm saying whenever the moment I say this, I'm saying xn has entered 2 epsilon room, right? So when will this enter? And it will remain same, right? It will remain in the 2 epsilon room forever, right? So I should say that such that xn is less than this for all n. I'm sorry. I think. So for all n greater than n epsilon, right? If you take a stage beyond n epsilon, all the numbers in that sequence will remain inside this epsilon room. And remember, this is always true for every epsilon greater than 0. So you can squeeze the room and make sure that it's very, very small, however small it is. Maybe if it is small, let's say 10 power minus 10, the stage could be 100,000, beyond which everything. If it's 10 power minus 200, then it could be 100 billion power billion, whatever, right? Beyond that, everything will be then. So this is the definition of convergence, right? Any questions on this? Clear? Okay. Clear? Sure? So there are notations for this. Okay, so what are the notations? Some people say xn converges to x and going to infinity. Some people say limit n tending to infinity, xn is x. Right? These are some of the standard notation. Right? This is just a shorthand. Right? So people cannot repeat this entire definition every time you write something about the limit. So this is just a shorthand. Okay. The inner meaning is this. Okay. So now, of course, there are certain properties, right? So what are the properties? I won't prove these things. Maybe you should try to see this, prove this. Xn converges to x, yn converges to y, implies converges to x plus y. Okay, fine. This is clear, right? If xn goes to x, what does that mean? Xn enters epsilon room, right, around x. Yn converges to y, what does that mean? It will also enter epsilon room around y, right? If you take the sum, you should enter a room around x plus y, right? I mean, it's very intuitive, but how do you prove that? Well, I will leave it as an exercise, or yeah, I will leave it as a homework problem. Okay, so alpha xn converges to alpha x for every alpha not equal to infinity. Okay, so mod alpha. You scale it, the limit should also be scaled. This is an easy proof. You can prove that pretty easily. Okay, so let's try to understand limit a little further. So what do you mean by epsilon room? So 1 over n converges to 0, right? This is something that we know. So suppose I give you epsilon. Okay, let's start with epsilon equal to 0.1. Now, can you give me a stage beyond which xn will be 0.1 close to 0? See, so this implies I want 1 by n minus 0 should be less than 1 by 10. 1 by 10 is epsilon, right? 0.1. Okay. So when will this happen? So this implies epsilon is 0.1 is 11. You take any number beyond 11, right? 1 by 11, 1 by 12, 1 by 13, 1 by 14, and so on till infinity, right? So it will always remain within 0.1 around 0, right? If you take epsilon equal to 0.001, what does that mean? 1 over n minus 0 should be less than 1 by 1000. So this implies n should be greater than 1000. That means n 0.001 is 1001, right? 1001, 1002, and so on. You take all the numbers will lie within 0.001 of 0, right? Okay, is this clear? This is what it means. This is what I mean by convergence. Clear? Okay. Yeah, because this is very important, because we will keep using that, right? So we say this is an algorithm which converges. That means you can implement that on a computer and it will stop after some time. You can stop and hope that you can be sure that you'll be closer to a good solution, right? So in order to ascertain that, we need to prove that something converges. Very, very important in algorithms. Okay, so I think I will, although I started late, but I'll stop on time. Next class onwards, we will ensure that this thing does not happen. Okay, so one last thing that I have to teach for today, so which is called an open set. Well, why do you need this? You might question and say, well, we are engineers, we don't need open set, closed set, all that. Well, that is true, but this is more of a fun and also jargon. Some people might read somewhere about open set. You should know what an open set is. So what is an open set? Any idea? Huh? You know what open interval is, right? So suppose I take this kind of sets. It's not an open interval because I cannot write it like that. Set of all x as that a less than x less than b kind of a thing, right? There are gaps here. Okay. So is there another class? No? No, right? Hopefully, yeah. So if you have union of intervals, open intervals, you'll get something different, right? So how do you define open sets? So the idea is interesting. So we say that set is open set if you take any point. Okay, so you take a point here. For example, in if I look at this point, I can put a small interval around that point such that this interval is sitting inside this set. Okay, you give me any point, maybe damn close to this interval, right? So very close to that open bracket, very close. I can still put a small bracket around that, but within the big bracket. So that small interval lies within the set, right? I can do no matter what. One example is, open interval itself is one such example, right? If you take an x which is very close to 1, right, I can still put a small an interval around this like this, right? It is still sitting inside the bigger interval, right? So that's called an open set. It should be able to do it for all the points. What about this? Is this an open set? Why? I have no problem with this point. I have no problem with this point. No problem. But I have a problem with this point, right? On the edge. So remember, this point here belongs to the set. It's a closed set, right? So if I use this, I cannot put any interval, right? However small it is, the right side will overlap with something outside the set. So it doesn't sit inside the set, right? So this is not an open set. Okay, so we will study more about this in the next class. So I said I will give the I will provide you the evaluation scheme. So I had bought that today. So what I will do is I'll put that online today and discuss about that tomorrow. Okay. So today or tomorrow I'll put that online. I'll give it to the TA, so they will take care of this. Okay. So tomorrow I want those who are sitting at hostel to be here. Okay. So please come here. I will decide whether to do it in this mode or completely offline mode, record and give the recording to those people who are not at IIT Dharwad. Okay, because this thing may not work that well, mixed mode. Okay. Okay, so any questions? Any questions?
Sir, can you explain that the 1 by n minus 0 in the interval, I mean, in the modulus greater than 10 part?
So
Connecting those
if you take epsilon, is there a class now? No, right? Huh? Okay. Hey, I'll talk. Just give me 5 minutes. Huh? Okay. Whose class is this? Huh? Yeah. You can tell him that he can come. So you guys can leave. Hello. Hey, somebody had asked a question, right? Are you still there or?
Yes, sir.
Yeah.
I was saying that I did not understand that part that you said about 1 by n minus 0 in the modulus is less than
Okay.
I believe 1, and it how the n epsilon went to 0 11. I did not understand that portion.
Okay. Just give me a minute. I'll just 2 seconds. Can you see the screen? I've shared the screen.
Yes, sir.
Okay. So now essentially what I'm trying to say is I have to show that whenever n goes to 0, right? Which is very intuitive, right? So what do you mean by that? Well, you take a room around epsilon room around 0, right?
Yes,
You understand what do you mean by epsilon room around 0?
yes, sir.
So here is 0. You have to take an epsilon room, right? So let's say I'll take a magnifying glass and let's look at the magnified version. So epsilon room is 0.1. Okay. This
Yes,
whole thing is the length of this is 0.1. That means this is 0.05 and minus 0.05. Okay. Now I have this sequence, right? 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5, 1 by 6, and so on. After some point in time, the sequence will enter this room, right? The room that I have shown here, and it will remain there forever, right? So what is the stage? I want 1 by n to be zero point 0.1 close to 0, right? That's what I have written here. So if that is the case, then n should be greater than 10, right? So I can write that 1 by n is less than 1 by
so it
10.
can
Then
be less than 10 also. Like there will be 2 points.
no, 1 by 9 is greater than what? 0.05, right? You
Yes,
agree?
yes.
So that means it's outside the room, right? It cannot be inside the room.
So I mean, means for the 0, there can be a left to that point and a right to that point as well.
Correct. So this is minus 0.05 and this is plus 0.05, right?
Yes,
So if you take 1 by n equal to 9, that is 1 by 9. 1 by 9 is definitely outside of this, right? Is
yes,
that correct?
yes,
Hmm?
yes, sir.
Yeah. So that means if n, unless n is greater than 10, you cannot be within this room.
Okay.
Do you agree?
Yes.
Well, is that correct? Did I make a mistake here? Let me just. I should not make some stupid mistakes. So let's say you have 0, right? I'm saying 1 over n should be less than 0.1, right? Or n should be greater than 1 by 0.1, which is equal to 10, right? N should be greater than 10 in order for you to be within 0.1. So sorry, here I think 0.1 is this is a positive number, right? So 1 by n should be within 0.1, right, of 0. So that means if you look at positive side, this will be 0.1 and it should be within that, right?
Yes, sir.
You agree?
Yes, sir.
So you can be within that only if this happens, right? Within n is greater than 10. If n equal
Right.
to 10, you will be here, right? 0.1. 1 by 10 is 0.1. N equal to 11, you will be here. N equal to 12, you will be here, and so on, and it will go to 0, right? N equal to 9, you will be here, right? Somewhere here, outside. Do you agree?
Right.
So I think the picture I'll correct it tomorrow. So I cannot use this picture, right? Minus 0.05 to 0.05. This is not correct. Okay.
Yes.
Is this fine?
Yes, sir. I got it.
Oh, Saurav, right? Yeah.
Yes.
Okay. Any other questions?
No, sir. I'll first try to prove these properties, then I'll ask you
Okay.
tomorrow,
Okay.
possibly. If
Okay. Yeah. Satvik, are you there? Any questions?
No, sir. No, sir.
Okay. Okay. Yeah. Thanks. Bye.